Hello. We are starting a very important series of lessons dedicated to AI security. In this series, we will examine how AI security differs from classical cybersecurity, what unique threats it brings, and which technical and governance instruments help turn risks into a manageable system. In this first lesson, we lay the foundation. We compare cybersecurity and AI security, highlight 5 key challenges, and link them to the core properties of a trustworthy system. We will conclude the lesson by discussing the distribution of responsibility. Therefore, I suggest subscribing to the channel if you haven't already. That way you won't miss new lessons. Please like this video if the topic of AI and its governance interests you. Let's begin. The traditional cybersecurity paradigm has historically focused on protecting information assets by ensuring their confidentiality, integrity, and availability, the so-called CIA triad. The objects of protection were infrastructure, networks, and applications. Attack vectors targeted vulnerabilities in code or system configurations. With the advent of complex AI systems, especially those based on deep learning, we are observing a fundamental shift. The attack surface expands to include the very decision-making logic itself. An adversary no longer needs to compromise the system at the infrastructure level, they can manipulate its behavior through carefully crafted inputs. This phenomenon represents a transition from implementation-level attacks to semantic attacks on the system. Based on this evolution, an AI model ceases to be merely a software component and becomes an independent, complex asset. Its compromise does not lead to classical consequences like denial of service, but rather to the generation of systematically incorrect yet plausible outputs. This creates a new class of business risks, making erroneous strategic decisions based on compromised forecasts, embedding latent discrimination through manipulation of training data, or eroding trust in automated systems as a whole. Thus, the problem of AI security extends beyond the competence of the IT department and becomes a subject of analysis and action for multiple organizational units. Before we move on to specific threats, we need to establish a solid conceptual foundation. Our ultimate goal in AI governance is to ensure the creation of trustworthy AI systems. But what exactly do we mean by trust? This is not an abstract emotion, but a set of measurable engineering and governance properties. To understand what trust comprises, let us analyze the fundamental challenges any complex AI system faces. These can be categorized into 5 main areas. The infrastructure challenge, internal failures of hardware and networks. The data challenge, anomalous, corrupted, and unforeseen inputs. The time challenge, gradual degradation of performance and stability. The adversary challenge, purposeful, malicious actions to compromise the system. The alignment challenge, a mismatch between the system's behavior and human values, intentions, and ethical principles. To counter each of these challenges, the system must possess a corresponding property. Let's now examine what those properties are. To withstand infrastructure failures, we need resilience. This describes how the system responds to major infrastructure disruptions, server failure, network outages, or data center blackouts. The system's ability to maintain critical functionality and rapidly recover after such events, that is resilience. These issues are addressed not at the model level but at the architectural level. Therefore, the primary focus on resilience falls on the strategy and planning stage, where we design redundancy, load balancing, and develop business continuity plans. To resist data-related challenges, we need robustness. Here the threat profile is entirely different. We are discussing the model's ability to respond adequately to anomalous, corrupted, or adversarially crafted inputs. This is a property of the model itself, its internal resistance to perturbations. Therefore, assessing robustness is a key task of the testing and validation stage. Essentially, this is a sensitivity analysis of the model's response to problematic inputs. To counter the time challenge, we need reliability. This term describes the system's behavior under normal, expected operating conditions. How predictable are its results? How stable is its performance over time? Reliability is a marathon, not a sprint. We evaluate it during operations and monitoring through performance KPIs, drift monitoring, and error rate tracking. To counter adversaries, we need security. Unlike all previous properties, security deals with resisting purposeful, intelligent, malicious actions. This is not accidental failure nor merely anomalous data, it is deliberate attack. Although security aspects are embedded at every stage, their operational assurance and threat monitoring remain ongoing tasks during operations and monitoring. To counter the alignment challenge, we need functional safety. This ensures that the system behaves in accordance with human values, intentions, and ethical principles, even under normal operation. Functional safety includes preventing harmful outcomes, ensuring fairness, transparency, and accountability, as well as controlling the system's potentially dangerous capabilities. This work is carried out at virtually every stage of the lifecycle. Such delineation helps avoid conceptual confusion and enables the application of adequate control instruments at the appropriate lifecycle stages. Assigning responsibility for AI security solely to specialized units such as the Information Security Department is a common, but erroneous practice. The complexity and multifaceted nature of the problem require a shared responsibility model. To operationalize this approach, it is advisable to use the 3 lines of defense framework. The first line comprises process and system owners, developers, ML engineers, and data scientists. Their responsibility is to implement technical controls and ensure model robustness during the creation stage. The second line encompasses oversight and control functions, risk management, compliance, AI governance, and information security. They develop policies and standards, conduct independent validation, including red teaming, and perform risk monitoring. The third line is internal audit, whose role is to independently assess the effectiveness of the first 2 lines and the entire internal control system in the AI security domain. It is critically important to formalize this distribution. This is achieved through developing a responsibility matrix, such as RACI, which must become an integral part of the AI system passport. This eliminates gray areas of responsibility, especially at handoffs between development and operations, where risks are traditionally highest. In this lesson we have defined the conceptual foundations of AI security. We established how it differs from traditional cybersecurity, introduced precise terminology, and reviewed models for formalizing responsibility. The next lesson will focus on systematic threat analysis and risk assessment methodology. That concludes today's lesson. See you in the next one.